Heading: Direct Memory Access, DMA. First point. Direct memory access is a technique that allows data transfer between I/O devices and main memory without continuous involvement of the CPU. Second point. DMA improves system performance by reducing CPU workload. Side heading: Principle of DMA. First point. The CPU initializes the DMA controller by providing the starting memory address, transfer count, and direction of transfer. Second point. The DMA controller takes control of the system bus. Third point. Data is transferred directly between the I/O device and memory. Fourth point. The CPU is free to perform other tasks during the transfer. Fifth point. After completion of transfer, the DMA controller informs the CPU through an interrupt. Side heading: DMA controller. First point. DMA controller is a hardware unit that manages direct data transfer between memory and I/O devices. Second point. It temporarily takes control of the system bus from the CPU. Side heading: DMA transfer process. First point. CPU loads the DMA controller with transfer information. Second point. DMA controller sends a bus request signal to the CPU. Third point. CPU grants the bus by sending a bus grant signal. Fourth point. DMA controller takes control of the system bus. Fifth point. Data is transferred directly between memory and the I/O device. Sixth point. Memory address is updated automatically after each transfer. Seventh point. Transfer count is decrement after each transfer. Eighth point. When the transfer count becomes 0, DMA operation ends. Ninth point. DMA controller sends an interrupt signal to the CPU indicating completion of transfer. Draw diagram. Side heading: Advantages. First point. High-speed data transfer. Second point. Reduces CPU workload. Third point. Improves overall system performance. Side heading: Disadvantages. First point. Additional hardware cost is required. Second point. DMA controller design is complex.